my primary design, I wanted to sort of just have like a spring mechanism inside of PVC piping, and then hollow out part of it, and sort of use like a lever action thing to cock it back and then set it in so that you can just release it whenever.
All right, and for my initial design, I was thinking about the same thing that Devin was kind of thinking with, but instead with a PVC, just using a Coke bottle, and there would be a string that would pull a platform back with a spring mechanism to launch our ping pong ball. And then also I was thinking that we would attach our launcher to some sort of tripod mechanism made out of either a plywood or a cardboard, and then just have hex nuts on the sides, and then you would just screw in screws at different heights to operate the tripod. And so for our final design, we sort of just combined the idea of using PVC and couplings along with the spring and string idea. And then also we decided we were just going to use the tripod mechanism that we talked about earlier. Here's our finished prototype. As you can see, we used rubber bands instead of a spring. Unfortunately, we couldn't find a spring that would work with our design, so yeah, we just used the rubber bands. Everything else is pretty much similar to what we had planned beforehand. So we're using nylon as a string to pull our platform, and then we made the platform out of foam board just as we had planned. All right, and then we'll have Devin over here talk about the efficiency of it.
All right, so I mean, like, it does the job. Our platform's a little bigger than the inside diameter of the pipe, so there's a lot of friction that goes on with it. So it doesn't fly as far as we want it to go, and it's not as accurate as we want it to be, but we'll make improvements on that as we go.
Yeah.
So a couple changes we made to our prototype. Max went into the shop and machined this down to 20 inches instead of 2 feet. And then he also put holes in the sides for like the rubber bands to go through. And then we also made a design change by using a pipe clamp to secure the rubber bands instead of using super glue.
All right, so yeah, sort of like what Devin was talking about, instead of using super glue, which would have the rubber band snap on us, we're actually using slip knots. Let me see if I can get this out of here. So we're actually, as you can see, we're using slip knots to secure our rubber bands. Unfortunately, we had our platform snap due to the new design, so we weren't really able to test today. So sort of for our final retrofit phase, we're just gonna 3D print a platform, so we just get a more solid design. So yeah.
So one of the changes that we made to our cannon is that we replaced our foam board platform with a more sturdy 3D printed platform, and Max just designed it in what, CAD?
Yeah, I designed it in Autodesk Inventor and then took it down to the makerspace and had him 3D print it for me.
Yeah, so it's a lot more stable now and it doesn't break.
Yeah, and then also our original plan of just holding the cannon wasn't really working out in our prior tests, so we added some legs to it. This is just some cardboard from some old posters I had. And then also, we were also having problems measuring the power of the cannon. So we added a ruler on the back end, and then we just measure how far we're pulling back the string to kind of regulate how powerful the cannon is when we're firing it. Alright, so this is Max again here. I made a few changes from the last test we did because we weren't really able to get the 3 shots that we wanted. So last time we were having a lot of trouble with the little handle here going up through the PVC over here. So I just tied the nylon to a little piece of plastic from a tape dispenser. And we're still using the ruler to kind of regulate power. Alright. And also I noticed that our accuracy wasn't very good because the ball was going left and right. So I added about a 9-inch barrel extension using the same tube from the posters that we used for the stands here. So yeah, and that got the accuracy we wanted.
Alright, so the strengths of our group, whenever we're all together, we're very productive. There's never been like a day where like we haven't really gotten something done. Our very first design was like pretty strong in general. For an idea, we didn't ever have to make too radical changes. Compatibility of ideas, like never really got into arguments about like, the best idea or like how to approach the problem in like a different way.
Our weaknesses, we had 3 weaknesses. Basically, it's hard to get all of your group members in one place. It's mostly availability. So like, either one week I'm not there, another week someone else is not there, and apparently this is like one of those weeks where everyone was there. Another one was production issues. There was a prototype, but it had some issues. So, and the final design, it wasn't really up to pat. So like there are some changes we need to make so that we get it done right. And third one was material acquisition. There were problems getting materials. Like, we had trouble getting the right spring to use, so we had to like switch it up to a rubber band and like little things like that. But in the end, we'll get it done.
Oh yeah, so like some challenges that we faced, like Ashton was saying. Our initial design was using a spring, but we couldn't really buy a spring that would work with our PVC pipe that we bought. So yeah, we had to end up switching to rubber bands. So you know, we had to do a bunch of redesigns to make that work. Also with those redesigns, we had a lot of failures. So like our rubber bands would snap initially, and then when we fixed that, we'd have to deal with the platform snapping. You know, just different failures with the designs we had along the way. Another challenge we faced was building location. Initially we were building at Dawson's house, and then we switched to using rooms that we rented from the library. But you know, initially it was really hard to find a good building location for our group to put together the product and test it. And then finally our last challenge is the accuracy of the launcher. When we were testing in our prototype, retrofit, and final phases, we were having a lot of problems with the launcher shooting the ping pong ball accurately every time, and hitting the target 3 times like it was outlined in the project.
Okay, so for changes, if we had to do it all over again, we'd have more coordination between each other with the materials and design, like what we wanted to get done. Also, researching materials would be like realistic to build it with, and making more realistic designs. Like you can design something that looks really cool, but if you're gonna make something that real, it has to be something that you can actually make.
Alright, so as far as disposing of our prototype, my mom had contacted me and said that her preschool would actually be interested in having a ping pong ball launcher. So we're probably going to end up donating our ping pong ball launcher to her preschool so they can, you can have it as a toy.
Second, we thought about using the materials we use for this project, whatever it is, whether it's a foam board, rubber bands, a spring, anything like for the future, so that we don't have to like spend time actually looking for the materials that we already have. So if you have any future projects coming up and you're using the same materials, it will be useful.
Alright, so another option for disposal, we could recycle the excess foam board since it's biodegradable. And yeah, we really don't have like a need for it either, so it'd be good just to like cut down on excess waste.
Then we're gonna save the tools for future projects, and we didn't have anything hazardous that we were building with, so we don't have to have any special consideration for that. Just donate the rest of them.